less than 9.5. We're going to do the sine and cosine ratios, part 1. All right, so we talked about the acronym you can use to remember was TOA, right? We already know tangent equals the opposite side over the adjacent side. So that's where the TOA comes in. Sine is going to equal the opposite side over the hypotenuse. And cosine is going to equal the adjacent side over the hypotenuse. That's why it's so important to know which sides you have in relation to the angle that you're going to work with. Okay, so if you have to find the sine of R and the cosine of R, here's your triangle. Okay, again, these only work for right triangles. Please don't use them for any other kind. 16, 63, 65. All right, so if we want the sine of angle R, sine is opposite over hypotenuse, right? So the sine of angle R, here's your angle, opposite side is 16, hypotenuse of the right triangle is 65, so the sine of R is approximately 0.246. Cosine of angle R is going to be the adjacent side over the hypotenuse. Cosine of angle R, the adjacent side to R is 63. Hypotenuse again is 65. So the cosine of R is approximately 0.9692. Okay, all right, so let's look at it in some problems that you're gonna see. Oh, actually this next thing is super important because I've seen questions. I used to skip this, but I've seen questions on the EOC that deals with this, so I made sure I wanted to put it in this year. All right. If this is a 90-degree angle, if angle C is a 90-degree angle, that means angle A and angle B must be complementary, right? Okay, because that's 90, they have to add up to 90 degrees in order for the triangle to have 180. So if that's true, which it is, the sine of angle A, hold on one second. The sine of angle A then would have to equal the cosine of 90 minus A. Right? Okay, so this is just something to remember. And the sine of angle A equals the cosine of 90 minus A, and it also equals the cosine then of angle B. So those three is, if those three, that relationship right there will always be true, right? Because these only deal with right triangles, so A and B have to always be complementary in a right triangle, which means this relationship is always going to be true. Okay, so I just want to put a little note here. Wouldn't angle B equal 90 minus angle A, right? Okay, so that's why this is true. I'll put angle A here. Okay, so a couple things. Sine of angle A is going to equal the cosine of angle B, right? And obviously the reverse is true. If you have the cosine of angle B given to you, you know that's going to equal the sine of angle A. Sine of angle B then would equal cosine of B. Why did I write that? Equals the cosine of angle A, and the cosine of angle A would equal the sine of angle B. All right. That seems probably kind of confusing, but I do want you to memorize that relationship because I feel like they gave like something that looked like this and people were like, what does that mean? But that's what that means. So if you can memorize that relationship, it'll help you. All right, let's try one. Write the sine of 56 degrees in terms of cosine. All right, so we're going to use this relationship. So the sine of 56 is equal to the cosine of 90 minus 56, which in terms is equal to the cosine of 34. Okay, so the sine of an angle will always be equal to the cosine of its complement. If we do this on the calculator, sine of 56 is approximately 0.8290. And if we do cosine of 34, also 0.8290. Cosine of 34, approximately 0.8290. Okay, so they are the same. And you just got to remember that. All right, let's try a problem. Okay, so we got a 90-degree angle, X, Y, 14, and 26 degrees. Okay, we're gonna find the values of X and Y. Okay, so every time you wanna know what sides do you have in relation to the angle that they give you. So, right, we are looking at angle 26. X is going to be the opposite side. Y is going to be the adjacent side. 14 is the hypotenuse. Okay, and once we know those, we can just plug in what we need. So, dealing with the opposite side, that's going to be sine, right? Because we have the hypotenuse right now, so we're going to use sine or cosine. So the sine of, oops, not 46, the sine of 26 is going to equal opposite over hypotenuse, so x over 14, which is nice because then we can just multiply both sides by 14, right? So x is approximately 6.1, and y is the adjacent side, so that one we're going to use cosine for. So cosine of 26 would equal the adjacent side over the hypotenuse. Again, we can multiply both sides by 14, and y is going to equal 12.6. Oh, approximately, sorry. Okay, one thing that I just want you to always check real quick. So if these are your two legs and this is your hypotenuse, just make sure you check to make sure the sides are not greater than 14. right? Because the legs can't be bigger than the hypotenuse. So just check and make sure when you get answers that that was true. Okay, what if you are given this triangle and they want you to find the sine and cosine. All right, so it's a right triangle and has congruent legs, right? If that's true, then it has to be a 45, 45, 90. Because if the legs are the same and it's a 90 degree, or it's a right triangle, it has to be that. Okay, so what do we know? If it's a 45, 45, I'm redrawing. You don't have to. You can just do it on the one above it, but I'm going to redraw. So if it's a right triangle and we know the legs are congruent and it's a 45, 45, 90, then we're going to name the legs or label them or assign them the number 1, and the hypotenuse then would be 1 times the square root of 2, or just the square root of 2. Okay, so the sine of 45 degrees would equal opposite over hypotenuse, right? Can't have a radical in the denominator, so we're going to multiply top and bottom by square root 2. Square root 2 times square root 2, excuse me, is 2. Okay, and that's approximately 0.7071. All right, let's do cosine. Cosine of 45 degrees is also going to be 1 over the square root of 2, right? So we get square root of 2 over 2 for that as well. So when it's a 45, 45, 90, the sine and cosine are going to be the same of those angles, right? So what can we memorize? The sine of 45 degrees equals the cosine of 45 degrees. And I would definitely remember that in radical form, it's square root of 2 over 2. And that's what I would memorize. You can always figure out the decimal part of it if you need it. Okay, so memorize that for sure. All right, next one. You are given, I'm just going to draw this little because I'm going to redraw it. So you're given a triangle and you're showing it's a 90-degree angle and that this is 30, okay? And we want to find the sine of 30 and the cosine of 30. So first thing you're going to do, label the legs and the hypotenuse, right? Okay, so this is what I meant. I'm going to redraw this so that, all right. So we had a 30-degree angle. We know this is going to be 60 then. We also know the relationship. So if you have a 30, 60, 90, make your side opposite the 30 a 1, make your hypotenuse a 2, and make your long leg square root of 3, because short leg times the square root of 3 is just square root of 3. All right, so sine of 30 degrees is going to be opposite over hypotenuse, which is actually a terminating decimal, right? 0.5. The cosine of 30 is going to be adjacent over hypotenuse, which can stay like that, right? It doesn't have a radical in the bottom. That's going to be approximately 0.8660. And now I'm going to have you guys try a couple. I want you to find the sine of 60 degrees, and I want you to find the cosine of 60 degrees. Okay, let's pause it here. right, sine of 60, then opposite over hypotenuse, which is approximately 0.8660. And what do we notice? That means it's equal to the cosine of 30. So what else should we memorize? The sine of 60 equals the cosine of 30. What do you think is going to happen down here? Cosine of 60. Cosine of 60, adjacent is 1 over the hypotenuse, which is 2, which is equal to the sine of 30. Okay, so extremely important. Memorize that. Memorize the sine of 45 and cosine of 45 are the same. Okay. All right, that's it.